They're going to describe a rectangle to us, tell us a little bit about the length and the width, and also the area. So what they tell us about the length and the width will help us label the figure. And what they tell us about the area will help us write an equation. So let me give you a minute to read it over, maybe even a couple times to start letting it sink in. Think about what we know about this rectangle and what we're trying to figure out. I see Shay has a hand up. Can we help with something, Shay? So they're asking us to find the dimensions, and what they mean by the dimensions is the length and the width. They're telling us that for this particular rectangle, the width is 7 miles less than its length. So when it says width is, that means they're getting ready to describe the width, and that's the part I want to translate and put onto my diagram here. How would you guys translate 7 miles less than its length? We can kind of leave the unit out of it. We just want to show 7 less than the length.
7 minus 6.
Subtract for less. That sounds good. Less than its length means we want to put the length first, and then the minus 7 after. So maybe just reverse it, x minus 7. And when we wrote that down, the x was in place of the word length, wasn't it? 7 less than the length. So we could also label the longer side with just an x. And then we would like to show that we're going to multiply those together to get our area. That'll help us write an equation. So remember how we said the length times the width. In this case, the length was the x times the width was the x minus 7. I probably would only put parentheses around the x minus 7, but either one of these would be fine, with or without. That's really the trick to getting started on these problems, is deciding how you're going to use your variables, like we did here with the x and the x minus 7, and then figuring out how to make an equation out of it. So a good time to pause, maybe go back, make sure that all looks okay to you. Anything you're not sure about, just ask. Anything we could help out with up to that point? All right, so for our solving, we want to think like we were just talking about in the previous section. We'd like the left side to be in descending order. In other words, the exponents should be descending. And the right side, we'd like it to be equal to 0. So it looks like we're going to need to do a couple things to make that happen. We're going to need to distribute the x on the left side, and we're going to need to move that 120 over. So distributing the x, that would make x squared minus 7x. And how can we move the 120 over? It needs to be subtracted, yeah, from both sides. So it'll end up being x squared minus 7x minus 120. And the exponents are descending like we wanted, the squared and then the x and then the number without an x. So distribute, move the number over, then think about factoring. got a trinomial, so I'm thinking about trial and error. I need to find two numbers that add up to -7, while at the same time multiply to make -120. 15 and 8, which one should be with the minus? X minus 15, that would make the 7 negative, and X plus 8. So give everybody a second to check and see if they like the looks of that. 15 and 8. Negative with the 15. Then we would separate and get our two solutions. So it looks like the 15 would end up positive and the 8 would end up negative. The algebra looks great here. The degree was 2. We ended up with 2 solutions. So far, so good. However, in this problem, remember X stood for the length of a rectangle. One of these answers doesn't make any sense as the length of a rectangle. What do you think looks kind of fishy?
The negative one?
The negative. Yeah, a length can't be negative. So we're going to need to just throw out and disregard that -8. We didn't do anything wrong. It's just in this problem, X stands for something that can't be negative. So we're going to have to stick with the positive, the 15. When it comes to giving our final answers on homework, it's often fill in the blank and a little drop-down menu. So they're probably going to give us a blank to fill in for the length, which is the one we called X. And then another blank to fill in for the width, which was the one we called X minus 7. So what about the actual solution 15? Is that going to be one of our answers? 15 is the value for X, and X stands for the length. So the length of this rectangle is 15. And if we put 15 in place of the X there, we can see that the width of the rectangle is 8. 15 minus 7 gives us 8. Next to each of those answer blanks would be a little bit of a drop down where you have choices for the unit. Can you look back in the problem and see what we would choose for the unit?
Miles.
Miles. Sounds good. Remember, for length and width, it's not squared, it's just plain miles. Only for the area would it be square miles. So there'll probably be a miles choice and a square miles choice, along with some other stuff. Who knows what else they'll throw in there. It's crazy easy to check these answers. If we just put them back into our length times width formula and make sure that they really make 120. Only takes a second to check and make sure they give us the correct area. So that's the plan, the process we want to follow for any of these area of a rectangle problems. Label the figure to show what the variable stands for. Write the equation so that we have something to solve. And those solutions will help us with our final answers, which we can check.